continue to work with solving systems of equations by elimination. What we're going to do is we want to be able to solve systems of two variable linear equations using elimination. And just when we are solving a system, the thought and the concept of elimination is if we have an equation and we're talking about two variables, so if I have y plus x equals 3, excuse my birds. Okay, and the concept of a variable is the variable is an unknown, so it wouldn't be possible to solve for two unknowns at the same time. So that's why we are going to work with the process of eliminating one of these variables to where once we eliminate one, that leaves just one left in the system that we can solve for. So that's what we're going to do, and by using the elimination method, we are focusing on opposite coefficients. That would identify an easy way to use the elimination method. And it is important to know that there are multiple ways to solve a linear inequation or linear inequality. But linear equations, we have elimination, substitution, graphing, and it's just a matter of recognizing the characteristics that allow one to be easier than another when solving. And as I look at the things when we're doing the elimination is this opposite coefficient. So, for example, if I have 2y and a negative 2y and a positive 2y, those would be opposite coefficients. And if I were to combine those, they would become 0y or just 0. And that's what we're going to be looking for. We're going to be looking for things that will disappear when I combine them or add them together. Because you remember that a system does work together. So that's what we're going to do is we're going to be adding them together. Using the elimination method. And just remember, looking back, we have when they intersect, right? That's looking at when this right here will be my solution, whatever value that is. I have these parallel lines which never intersect, and then I have the infinite number where I have two lines on top of each other. They're the same line and they connect and touch solution-wise infinitely. So there you have it, a quick snapshot of using the elimination method when solving system of equations. So here's an example. So I want to solve this system using elimination. So this example, remember that this is indicates a system, and these two equations work together. And I have negative 2x plus 4y equals 16, and 2x plus 2y equals 8. And we are going to combine these, as the system works together, we're going to go ahead and combine them and create essentially a new equation. So I go ahead and combine like terms, and negative 2x and 2x become 0. So that's 0x, and then plus 4y and 2y become 6y, and then 16 plus 8 is going to be 24. So then that is really just 6y equals 24, the identity property. And then going ahead and solving here for y, I'm going to divide both sides by the coefficient. That's going to be 6. So this simplifies down to 1y equals 4, or just y equals 4. Okay, I solved for one of my variables. I eliminated the x and then was able to solve for the y. And in order to now determine what x is, what I can do is I'm going to use substitution. And I'm going to take y equals 4 and plug it back into one of these original equations. So if I use this one, 2x plus 2 times 4, because y equals 4, then I can go ahead and continue to solve, and I have 2x plus 8 equals 8. Subtract 8 from both sides. 2x equals 0. Divide both sides by the coefficient, and x is going to be equal to 0. So my solution here is going to be the ordered pair of 0, 4. That is my solution. And that is using the elimination method, easily identified and easy to use when we have opposite coefficients, right? Negative 2 and 2, opposite, easily eliminated. and I'm able to process down my one variable, input back in over here, solve for my other variable, and then that creates my ordered pair of my solution. Systems of equations. Now we do have special cases. So what are special cases? Well, if this system, let me see, well, in order to solve a system, we do need to be lined up to where we can combine, and if you'll notice, that's wrong. That should just be -4. These aren't lined up, so what I need to do is I need to make sure that my variables and my equal signs are lined up. So I'm going to go ahead and reorder this one. And so I'm going to do that by just subtracting 2y from both sides. And that will give me negative 2x minus 2y is equal to -4. And I'm going to go ahead and rewrite this equation just so I line them up. And I have 2x plus 2y equals 4. Now when I go and combine those down, I end up with 4 minus 4, which is going to be 0. I end up with 2 minus 2, which is going to be 0y. And 2x minus 2x is going to be 0x, so 0 equals 0. And what that tells me is it's a special case, and that actually means that we have an infinite number of solutions. And as such, if I were to do a little bit of manipulation, an infinite number of solutions means that ultimately these two lines are equal, and when they're graphed, remember, that means that they are graphed on top of each other because they're the same line. That's why they have infinite number solutions, because they touch each other infinitely. Now, another option might be this equation over here, and so this special case, and I just created this really quick, but if I go ahead and combine my system, this is going to come down to be 0x, this is going to come down to be 0y, and this is going to come down to be 8, so 0 equals 8, and that's not true. So when it's not true, that means there is no solution. And if there's no solution, that means on the coordinate plane, right? If it's no solution, that means those things are running parallel because they never touch. Okay, so those are special cases. We either have no solution or infinite solutions. Okay, so, and then finally here, just looking at a problem and following the steps. So again, solving a system, given a system, we want to make sure that we do the alignment. So let's go ahead and align it. And in doing so, let's see, I probably would go ahead and subtract 6 from both sides here. And that is then going to give me 4x minus 2y is equal to -6. Now, this one I'm going to have to add 3 to both sides. So that is going to give me -7y is going to be equal to 10x plus 3, and I'm going to go ahead and subtract 10x from both sides. And that is going to give me -10x minus 7y is equal to 3. So I have -10x minus 7y is going to be equal to 3. Now this system, there's my realigned system. And now what I need to do is, since I don't have opposite coefficients, I am going to have to multiply one of those lines to end up working for these opposite coefficients. And what I'll do is to get an opposite coefficient here, I need to have the lowest common multiple would be 20. So if that's the case, I can take this whole equation and multiply it times 5, because that will give me 4x times 5 is going to give me 20. And then if I take and I multiply the entire other equation by 2, then that would end up giving me a -20x, and that would give me the opposite that I'm looking for. So when I do that, I end up with multiplying this equation by 5, I end up with 20x minus 10y is equal to negative 30. And then multiplying this line, this equation by 2, I get negative 20x minus 14y is equal to 6. So there you have it. There's my new system after I've done some multiplication. And you may notice that by doing that, I created the opposites, the opposite coefficients that I was looking for. I multiplied both lines by something to meet that least common multiple. So now when I combine them, this becomes 0x, this becomes negative 24y, and that is going to equal negative 24. So I have negative 24y is equal to negative 24. Divide both sides by the coefficient, and then y then is going to be equal to 1. So I have found the value of y, and in order to find, once I do that, so I have aligned, I multiplied, I have eliminated one variable, I have solved, and then I'm going to substitute now. I'm going to substitute the value of y back into one of my original equations so I can find out what x equals. So in that case, I will take this original equation, so I have negative 3 minus 7y is equal to 10x. And we said that y is 1, so I'm going to go ahead and place a 1 there. So I have negative 3 minus 7, because negative 7 times 1 is negative 7, equals 10x. So negative 10 equals 10x. Divide both sides by the coefficient. That means x is going to be equal to negative 1, or x is equal to negative 1. So my solution set that I've come up with is x is negative 1 and y is 1. So there you go. And if I were to check that, I would just put my x and my y back into my original equations, and it should work out. And in doing so, let's just take that top equation. So I have 6 plus 4x minus 2y equals 0. Well, we said y was going to be the value of 1, x was going to be the value of negative 1, so I have 6 minus 4 minus 2 equals 0, and sure enough, 6 minus 6 equals 0, or 0 equals 0. So yes, that does check. So there you have solved